Welcome students again into the 12th science chemistry class. From last lecture, from yesterday, we are learning the third chapter, that is this chemical equilibrium. Now in this ionic equilibrium, we already learned about that. Into that ionic equilibrium, there is the balance of the ions and unionized molecules into the aqueous solution. Now into that we also learn about the electrolytes and non-electrolytes, the substances which ionize or dissociate into the ions into the aqueous solution are called as the electrolytes, and all that is the acids, bases and salts are electrolytes, and the non-electrolytes substances are that substances which do not ionized into the aqueous solution, they remains as the molecules, and most of the organic substances such as sucrose, glucose, fructose as well as that is the urea, these are the non-electrolyte substances because they do not give the ions. Now let us learn more about the acids and bases. Now we also learn about the strong electrolytes that are the strong acids and strong bases which almost completely ionized. So into that again we learn about the strong acid that such as HCl, that is the hydrochloric acid, nitric acid, sulfuric acid, these are the strong acid. Now let us learn about more that of the acids and bases into these different theories. The first theory of acid and bases is the Arrhenius theory of acids and bases. Now in the Arrhenius theory of acids and bases, he first give the conceptual definitions of acids and bases. Now acids are the substances which contain hydrogen into them and they give the H plus ion when they dissolve into the aqueous solution. So according to the Arrhenius theory, acids and bases are defined as follows. Now acid is a substance which contain hydrogen and give rise to H plus ions in aqueous solution. So most of the substances are considered as acids according to this theory which give the H plus ion and which contain the hydrogen, such as for example hydrochloric acid HCl, acetic acid, all the organic acids such as acetic acid, benzoic acid, succinic acid, so many acids, that is the formic acid, all these are the acid because they contain the hydrogen and they give the H plus ions. They give rise to the H plus ions. Now when the hydrochloric acid dissolve into the water in the aqueous solution, it gives H plus ion and Cl minus ion. Now this acetic acid also get ionized, but acetic acid is the weak acid as it is the organic acid. So here are the double head arrow, and due to that there is the equilibrium between the ionized ions, that is the ionized molecules, and non-ionized molecules. Now this acetic acid is ionized as CH3COOH, aqueous gives CH3COO minus ions and H plus ions into the aqueous solution. Now Arrhenius described these H plus ions of, that is the acids in water, as only the bare H plus ions. But actually the H plus ions are not present into the aqueous solution. They are always get hydrated with that of the water molecule and they present as the hydronium ion, that is the H3O plus. But for our convenience, we always write the H3O plus ions as the H plus ions because there, that is their enthalpy of formation are same. So Arrhenius described H plus ions in water as the bare H plus ions, but actually they are present as the hydrated H3O plus hydronium ion in aqueous solution. But for convenient, we represent them as the H plus ions. Again base is a substance that contains OH group into them. How Arrhenius described the base? Base is the substance that contains OH group and produce OH minus ions, that is the hydroxide ions, in aqueous solution. So base is the substance which contain OH group and which produce the hydroxide ion, that is the OH minus ion, into the aqueous solution, and due to this most of the substances containing the OH group such as the NaOH, NH4OH, KOH, AgOH silver hydroxide, MgOH twice magnesium hydroxide, AlOH thrice aluminum hydroxide, most of the compounds are considered as the bases because they give the OH minus ion, that is the hydroxide ion, into the aqueous solution and they contain the OH group. Therefore, this NaOH aqueous ionizes as into the water Na plus aqueous plus OH minus aqueous, and this ammonium hydroxide NH4OH, this is the sodium hydroxide NaOH, and this NH4OH is the ammonium hydroxide which is the weak base. So there is the double head arrow and there is the equilibrium between the ions and the unionized molecules. Therefore NH4OH aqueous ionizes as NH4 plus aqueous plus OH minus aqueous. Though student, this is the very useful theory and which gives the useful definitions of acids and bases, but there are some limitations in this theory such as the ammonia-like molecules or ammonia-like substances or amines, primary, secondary and tertiary amines-like substances. They are basic in nature but they do not contain the hydroxide ion. Though they do not contain the hydroxide ion but they are basic in nature. And another drawback or limitation of this theory that they define the acids and bases, Arrhenius define acid and bases with the help of the aqueous solution. That means the substances which give H plus ion into the aqueous solution, they are acids, and the substances which give OH minus ions into the aqueous solution, they are bases. But if there is the no aqueous solution is there, then the hydrochloric acid is that not acid but still in the gaseous state or into the vapor state. Though there is the no water, the hydrochloric acid is the acid. Such limitation will be there of this Arrhenius theory. And let us learn the next theory, that is the Bronsted and lowery theory about the acids and bases. Now pay attention students, again on the blackboard. Now as I told you, there is the some drawbacks or limitations of Arrhenius theory of acids and bases, and that limitations are Arrhenius theory accounts for properties of different acid and bases and is applicable only to aqueous solutions. That means the acids and bases which gives H plus and OH minus respectively into the aqueous solution, they are considered as acids and bases respectively. The another drawback is, and it does not account for the basicity of substances like ammonia NH3 and Na2CO3, sodium carbonate or sodium bicarbonate, which are basic in nature, still they do not contain the OH minus ions. So these ammonia-like substances and the sodium carbonate-like substances do not have the OH group, still they are basic in nature. Now let us learn the another theory, that is the lowery and Bronsted theory. To overcome some limitations of this Arrhenius theory, the two different scientists, Bronsted and lowery, works on the acids and bases. And according to this theory, acids and bases are defined as follows. Acid is a substance that donates a proton. Acid is a substance that donates a proton, that is the H plus ion, to another substance. So all the substances which can donate the H plus ion, that is the proton, to the another substances are considered as the acid. The substances which only donate the H plus ions are considered as the acid. That means proton donors are acids. And what is bases? Base is the substance that accept a proton from the another substance. That means in the definition of bases there is no OH minus ions is considered. Here bases are the substances which accept a proton. So most of the substances are considered as the bases if they accept the proton. That is, proton acceptors are bases. Now, base is a substance that accept a proton from the another substance. For example, here, see here, this is the HCl. Now, it can give the H plus ion to this base ammonia, NH3. So, when this HCl gives the H plus ion to the ammonia, it becomes NH4 plus. Because the H plus ion is given to this NH3, there is the lone pair of electron on this nitrogen, and due to that, the H plus ion get bonded here, and there is formation of NH4 plus. And what is remaining? Only the Cl minus ion is remaining here. Now, as this HCl gives the proton to the another substance, that is the ammonia, HCl is the acid, and as ammonia accept the proton from this HCl, so ammonia is the base. But here, two pairs of acids and bases are, that is, formed during their reaction. Now, how they are? Now, this HCl when gives H plus ion to this ammonia, there is formation of this Cl minus ion. Now, Cl minus ion still have the attraction towards the H plus ion. So, it can again accept the electron from this NH4 plus ion. So, as Cl minus ion can accept proton. So, it is the base. So, the acid first generates the base first here. And this base second, that is the ammonia, which accept the H plus ion from this HCl, generates the another acid too by accepting the proton, because this NH4 plus again can give the proton. So, it is the acid 2. In this way, there is the conjugate acid base pairs are formed. Now, this acid 1 forms the base 1. Now, this acid 1 and this base 1 are the conjugate, that is the self-generated acid base pairs. Conjugate means self-generated acid base pairs. And this base 2 can form this acid 2. That means these are also this is also the conjugate acid base pair. So, two different conjugate acid base pairs are formed during the reaction in this Bronsted and lowery theory. Now, again, let us learn the another examples of the acids and bases in this theory. Again, pay attention, students, on the blackboard. Now, in this reaction, that is the HCl and ammonia, the HCl and NH4 plus ion, these both are proton donors. So, they act as the acids. And the ammonia molecule and Cl minus ions are proton acceptor. So, they act as the bases. And the products which are formed by this reaction of lowery and Bronsted, acid and base, are also the acids and bases. That is self-generated acid and base. And that are called as the conjugate acid and base. So, the products of Bronsted and lowery acid-base reactions are also the acid and bases. The base produced by accepting a proton from an acid is the conjugate base of that acid. That means the base which produced by accepting the proton from an acid is the conjugate base of that acid. And likewise, the acid produced when a base accepts a proton is called as the conjugate acid of that base. So, here see here, this HCl, this water molecule accepts a proton from this HCl, and there is formation of the another acid. So, it is the conjugate acid of this base H2. This H3O plus. By accepting the proton from this HCl, it forms the H3O plus, and this H3O plus can give the H plus ion again. So, it is the acid. So, this base which accept the proton from the another substance give rise to the acid, and this acid is called as the conjugate acid of this base, as well as the acid which donate that is the H plus ion to the another substance. It forms the base again, this Cl minus, because Cl minus ion can accept the H plus ion, so it is the base. So this acid produce the base Cl minus ion. So Cl minus ion is the conjugate base of this acid HCl. That is there. So the base produced by accepting the proton from an acid is the conjugate base of that acid. And likewise, the acid produced when a base accepts a proton is called as the conjugate acid of that base. Thus, a pair of an acid and base differ only by a proton. So, the conjugate acid and base pair, this HCl and Cl minus, this is only differ by only the H plus ion. Again, this H2O and H3O plus is only differ by the H plus ion. So, the pair of an acid and base differing only by a proton is said to be conjugate acid-base pair. Now, see student, here this water accepts the proton from this H plus ion, so it acts here as the base. But sometimes this water can also donate the H plus ion to the substances such as ammonia like, and in that case the water acts as the acid. So water have the dual nature. It acts as the base when it comes in contact with the stronger acid than it. But it acts as the acid when it comes in contact with the base such as ammonia. And in this way water have the dual nature. So water have the amphoteric nature. Amphoteric nature means dual nature. Now this is about the Lowery and Bronsted theory. Now let us learn the next theory, that is the Lewis theory, into the next lecture. But if student you understand this Arrhenius theory and Lowery-Bronsted theory of the acids and bases very well, then you can like, subscribe and share this video to the another class and colleges students, so that they also have the benefit about these theories of the acids and bases. So thank you for watching this video again.